Good day, and welcome to Blue Water's webinar on poultry processing wastewater. My name is CJ Strain. I will be your host today. I am the Chief Technology Officer for Blue Water Technologies. My background is in chemical engineering, and I've got roughly 14 years of experience in system development and implementation of technology across a broad spectrum of industries. Today I want to thank you all for joining me on this webinar. Again, we're going to be focusing on managing wastewater streams in the poultry industry. And our focus will be primarily on process equipment. We will be covering an overview of challenges associated with process water handling management, various process solutions, and case histories for economic phosphorus or discharge compliance, I should say. And when I talk about discharge compliance, I'm talking about volume of water, BOD, TSS, nutrients, etc. So let's get started. I'm going to begin by putting a specific description to the challenges, as I believe that is very important for developing a solution to any water or water management challenges. Many water systems provide poor treatment results, and there's multiple reasons for this. Sometimes it's poor design or a rushed design. Overloaded systems, they were designed for hydraulic loads or solids loading that was historical, 10 years ago, and capacity of the plant has increased with production, or needs to increase with production. So quite oftentimes an outdated or an overloaded system can create economic issues because you're not achieving a high quality of treated water. So that can be a real financial issue because that can create surcharges or fines due to discharge noncompliance. And what I'm going to also cover throughout this webinar, this conversation, is how a retrofit can alleviate some of those loading issues, and also how a retrofit can add other compliance components to your system, such as nutrient control. There's other things that we could do with overloaded systems to take that loading off and really increase the performance and therefore reduce the operating costs. I've mentioned nutrients a couple of times. It's something that historically has not been a huge compliance issue, but it is increasing in importance, especially throughout various states in the southeast, along the eastern seaboard, really. And so I'm going to discuss briefly some nutrient issues and compliance considerations as well towards the end of this webinar. But primarily I'm going to focus on getting the most out of your existing system, either through a retrofit or something of that nature, and capturing some of the lost revenue from what are currently regarded as waste streams. Many plants in the industry have a minimal treatment and minimal treatment integrated into their existing process, and therefore they discharge to local sewage works. The primary expense in this situation is often in surcharges. Regardless of whether the facility discharges to a city, though, or has its own biological plant, this slide illustrates where much of the water management expense is incurred. So this is just a broad diagram of potentially a kill plant where you have separate flumes to separate out the various waste streams. And you may or may not have some screening, equalization. Typically, what we see in most of the plants that we go into retrofit or help redevelop or redesign the treatment system is there's minimal treatment such as a DAF system. DAFs can be very economical as far as they give you a high level of treatment and a compact footprint, but once they're overloaded, etc., they can lead to extremely high operating costs. So here I have circled very high chemical costs or input costs for a DAF treatment system. And typically, if you're discharging to a public works system, you're paying surcharges to that system. A DAF will obviously reduce that to some extent, but typically those surcharges are going to be mass based on BOD, TSS, Quite often nutrients will be on that, as well as total volume of water discharged. So whatever treatment system a plant might integrate is all to reduce those. Unfortunately, a lot of the systems that we've seen are overloaded, and therefore the operators of the poultry processor is paying much more in surcharges than they really need to. So there's another there's where a lot of the expenses incurred is in those surcharges. And then another consideration when there is some level of treatment, in addition to the surcharges and operations costs, the chemical, the power, there's also the sludge management. And quite often that sludge management, those costs involve anything from power equipment to concentrate or dewater that sludge on site, hauling costs, disposal costs, whether to a landfill or what have you. But there are significant costs involved in sludge management. So with this as an overview of where a lot of those costs are incurred in the water treatment process, let's transition to some of the solutions that Blue Water can provide to help alleviate those costs. Blue Water's primary goal is to save you money by working with you to improve your existing facility treatment capabilities. Blue Water is a very capable industry partner, specializing not only in unit process design, but also bringing a broad experience in cost-effective solution development. So we provide not only equipment, subunits to a treatment train, but quite often we will package together treatment solutions. And the benefit to that really is, in case the plant, the facility doesn't have their own engineer, which is it's kind of a rarity to have your own engineer, is we do provide turnkey solutions and help you integrate them on site. That reduces your overall product costs or project costs, working with a design build equipment supplier such as ourselves. And then we also work in a variety of industries very closely with engineers and understand the nuances of that communication and that interchange to providing a very capable system. So you see some pictures and examples of package systems and unit operations that we've supplied to facilities throughout the U.S. There we go. Over the following slides, I'm going to be highlighting the benefits of various treatment stages that I had mentioned on the last slide. And I will begin with the EcoMat rotating belt filter, highlighting what Blue Water sees as a critical treatment stage to any water discharge system in the poultry industry. Here you see pictured one of our larger units. This unit will treat roughly 1 million gallons per day. So it's got a very small footprint. And over the next few slides, I'm going to highlight some of the benefits of that. But really, this is key to a well-functioning poultry application or a poultry water treatment system. So I'll take a moment to summarize where the EcoMat and why it's a critical piece, subunit, to an efficient process water system. So a lot of the expenses that I noted, you can achieve a cost reduction with this unit. The EcoMat's got a very unique filtering capability, so its efficiency is much greater than that of a drum filter, for example. And it removes high amounts of TSS and BOD, upwards of 50 to 80% TSS, up to 50% BOD as well. And that could be moved as a completely mechanical process. So there's no chemical costs. It's very low power cost for this system, as I'll highlight later on. So there's some very stark cost reduction capabilities with this unit process. In addition to that, when what we've recognized over the last few years of integrating this piece of equipment in the poultry industry is you can capture or recapture a revenue stream. The solids that are collected, if you're doing so without chemical, can have some value to them in rendering. So this, as I mentioned, captures between 50 to 60% of the solids out of the waste stream, which is a significant amount when you're talking about a waste stream that might have a couple thousand milligrams per liter of TSS. So there's a rendering value to that. In addition to that, if you can capture early enough in the process, your grease value is much higher. Yellow grease, for example, sells or is a commodity currently priced between 40 to 50 cents per pound. So there's some value in that stream. And in capturing that value, in addition, you get a reduction in your sludge management disposal costs as well. So there's some other facets to this treatment process that we like to point out. And that's typically how we'll have a very positive payback when we retrofit or do a new installation with this piece of gear integrated into the treatment solution, the treatment train. Typically, the payback is anywhere from less than 1 year to less than 2 years. So a very positive payback on this piece of gear. Some of the key benefits, again, are highlighted in this broad process flow diagram. The EcoMat is a low-energy input subunit that saves money by reducing chemical, increasing effluent quality, and by producing that value-added solid slurry, as we mentioned. So typically, as I mentioned, a lot of DAPs that are discharged into a public works, or a lot of treatment plants attached to poultry processing, poultry kill plants that discharge to public works systems, they have DAP systems or some sort of screening. So quite often there's already a system in place, whether it's overloaded or not. The nice thing about retrofitting the EcoMat is it's very small footprint, easy to retrofit, but it takes, over 50% of the solids loading off of an existing treatment system. Just, with that small unit process. That's a huge reduction in chemical usage. That's a huge reduction in power usage. And it leads, again, to a higher effluent quality coming out of the back end of that, whatever that existing process might be going to a public works system. And again, there's that rendering stream. Now, if the plant has its own biological treatment process, again, this will help with any overloading issues because you're taking 50% of that solids loading, up to 50% of that BOD loading off at the front end. So that biological treatment system can maintain a compliance level that much easier and more cost effectively. So I mentioned drum screens earlier. The EcoMat's been integrated, downstream of primary drum screens as a secondary barrier. It's been integrated as the primary and only screen on a treatment process as well. So here's a rough comparison of the EcoMat rotating belt filter operating in parallel with drum screens for operational comparison. So here you have the effluent quality coming out of a rotating belt filter with the same influence stream. And you have 2 drum screens actually in series that are operating to reduce TSS and pull out the rags and the larger particulate. So you can see those series drum filters or drum screens are doing, almost not worth having them in series. But typically, they don't remove a high amount of solids. You can see roughly a 12% reduction was achieved with the drum screens compared to the EcoMat rotating belt filter, which not only did accomplish the screening, but gave you a 50+% reduction in TSS removal here as well. And then there's a BOD comparison as well. So you can see that this significantly higher treatment capability than a primary or secondary drum screen, and that's how you get the cost reduction downstream. So again, one more slide to compare drum screens. There's also a footprint reduction as well. So there's a typical drum screen in the upper left picture with sludge conveyance, dewatering. Some of the typical issues that our customers have seen with drum screens is there's issues with blinding. They're fairly difficult to clean and maintain. They use a lot of wash water. And there's significant downtime and man hours for maintenance. On the right-hand side, we have our EM15 EcoMat unit, which is roughly a 1.4 MGD treatment system capacity. It depends on the solids loading. But it removes 4 times the amount of TSS. You recover 50+% of the material from that waste stream, and that's a renderable product. And it's a fully automated system, a very efficient cleaning system, very low wash water, and very low operations costs. The operations power input for this system averages about 2 to 4 horsepower. So it's very low power input for the level of treatment that it provides. And it's very reliable, engineered for to be very sustainable in a variety of applications, not only the poultry industry, but we provide this process to a variety of industries, including municipal sewage industries as well. As I mentioned, the bottom line is money and cost reductions, cost savings. You can save money in terms of space, capital, redundancy, flexibility. Money takes many forms in these capital projects, and sure just kind of illustrates a comparison. This picture illustrates a comparison between a conventional clarification system and our EcoMat rotating belt filter. So you can see that there's a huge difference in footprint. You can see this is actually on our production floor. There's a unit here in the back that's a 1 million gallon per day treatment process. And then on the left side here, you see a conventional clarification system. Now, again, this is a conventional clarifier. A DAF system is slightly smaller. But you can see that there's significant footprint differential. The EcoMat is very easy to install because it's because of its footprint. You don't have extensive earthworks or concrete design costs, engineering costs, engineering the pad even. All of that can be very expensive. So if one of these systems is being installed, there's a lot of upfront capital advantages to this treatment system. Then there's the raw material cost savings and the power savings, as I've mentioned in the previous slides. So illustrating the benefits that I've highlighted is this case study for a Blue Water provided rotating belt filter in South Carolina. This was installed as a secondary screen. They did have a drum screen as their primary. They had no further treatment. They didn't even have a DAF system actually at this particular location. So they just had screening, then discharge to the public works system. So this particular plant was a kill-only plant. They averaged between 0.6 and 1 mgd peak flow for their processed water flow through this plant. And the install reduced the surcharges to the public works system, and through recovery of renderable materials, they had inside of a year payback. And there's a couple of figures on here. One, this has been operating since February 2011, and they average roughly 6 to 8 pounds of dry solids per 1,000 gallons of processed water treated for rendering. So that, again, that just illustrates a positive economic scenario where this rotating belt filter can have a very positive impact to the overall economics of the poultry processor. And again, this is a reference from that plant in South Carolina. So very happy with the installation. With all of our installs, not only this particular technology, but with all of our product lines and process solutions, we have several recommendations and references that can be supplied by request. I want to transition and give you further definition on our rotating belt filter and examine how it works. You know, how does it function? What level of treatment will it provide? We've touched on that briefly, but I want to give you some more detail. And I want to describe a little how it ties into your plant, or how it could tie into your plant, and what it will do for primary and or secondary screening. Let's first talk about its method of operation. In this slide, you see illustrated, you see a cross-section of the unit. So there's a steel can, and there's a cartridge on which a rotating a continuous loop mesh is mounted for screening and filtration of the water. Now, this is a cartridge. It can be removed from this system. It can be mounted in a concrete channel even. But for the purposes of our conversation, I'm just going to use this cross-section to further the conversation. So the theory of operation, the methodology of solid separation, is that the screen will build up more and more solids and form a thick mat, which will filter out more and more smaller and smaller particles. So that's how you can get those high efficiencies of capture. So the belt travels in a upward direction, and it's cleaned on the backside. So as it comes around the bottom end, it's a clean mesh. So you get screening to the pore size of the mesh, and typically we'll use a 350 to a 500 micron mesh. And as you collect more and more particles, you start building a semi-porous mat. So you get filtration as that mat thickens. So your particle size, or your effective mean filtration size, decreases as that mat grows thicker and thicker, and therefore your capture increases as well. Now, as that solids mat becomes thicker, there's a VFD drive which will increase or decrease the speed of the belt as needed. So as the solids are captured, they come around the front end, and they're actually discharged. The captured solids are discharged into an integrated hopper with a screw that either can convey the solids, and in some cases we can dewater the sludge as well. It depends on the particle size of the solids that are captured from the stream. So here's a couple of pictures of that, of the ecomat in operation. So you can see there's an influent level set point in these in the influent side of the unit. So you build some water head, and that mat is shown here forming on the screen. So as that mat again gets thicker and thicker, that the belt speed can increase. If flow goes down, or if the strength of the stream decreases regarding solids, the speed will also decrease as well automatically. There's a pressure sensor to drive that system. So you can see that mat building up and being conveyed out of the water. In this next picture, you can see the top end of the roller where the solids comes over the top and is discharged into a sludge conveyance or dewatering hopper. There's a screw in this hopper here, and you can see that in some situations, again, I mentioned it depends largely on solids particle size and the amount of fibrous material that's remaining in the waste stream, whether it can be dewatered or not. But here's a couple of two pictures of applications where dewatering was achieved. And again, that's cost reduction in solids management and solids handling, and is also providing a drier stream to a renderer for rendering out the fats and the proteins. So just another shot of that sludge conveyance. You can looking down into the hopper in this upper left-hand picture, you can see a conveyance screw, and depending on the solids makeup, again, you can have a solids discharge, or it might look more like a slurry that's roughly between 7 to 10% solids. Sometimes those slurries, even though they're soupy, they're slightly higher in solids because the moisture content is pretty low. There's actually a lot of grease in there and a lot of smaller particulate. And I want to point out before moving on that Blue Water can demonstrate this process in a variety of ways. We do a lot of pilot systems and pilot programs around the country where we'll demonstrate the capability of the process before going into design. And there's a variety of ways in addition to piloting where we can, say for example, bench test. We actively pilot, but we also provide bench test simulations that predict the performance prior to even coming on site for a pilot. So if you're interested in a pilot, we just actually gave one away at the Poultry Expo in Atlanta. But if you want to prove out this technology before going into a design to estimate and simulate how much solids can be removed and estimate the rendering savings, the O&M savings, chemical reduction, etc., a pilot is a good way to do that. I'm going to take a minute to look at the internal components of this system a little bit more. For one thing, that continuous looped mesh that you see mounted on the cartridge here in a couple of the photos. So here's a cartridge out of the belt in this lower photo, or out of the machine. You can see that it's a polyester mesh. The belt is self-aligning. It's cog-driven. And there's multiple sieve sizes available, but as I pointed out before, typical sieve size for the poultry industry for a poultry processor is going to be between, I'd say, 3 and 500 micron. And these belts are designed to be very long-lasting. Typically, the belt life is 1 to 3 years, and they're very simple to change out. To handle waste streams with high amounts of oil and grease, which you typically have in poultry processing the waste stream, there is an integrated hot water wash. Now, we've used this EcoMat rotating belt filter in a variety of different applications, including beef, sausage processing, a lot of different applications where there is a high amount of grease. And this periodic degreasing works very well. Typically, we program this to come on maybe once every 30 minutes or once every hour, typically a 30 to 60 second wash. So low volume, typically 2 gallons a minute for most of our single units. And so a very low volume degreasing wash that can simply maintain that high level of performance and separation for this unit process. The cartridge mount configuration is really what makes this technology so expandable in treatment capacity. Blue Water has 4 base cartridge sizes integrated in a flexible and capable product line. The modular nature of the machine means it can be integrated on any flow range. We've integrated these on some sausage producers that have flows averaging 30 gallons a minute. I would say the majority of our poultry kill plants are in excess of 1 million gallons per day, up to 2 million gallons per day. That's a fairly typical range for how these are installed. But again, we can handle any treatment capacity because of the modular nature of this technology and equipment. Here's just a couple of production photos to share with you. These are units on our shop floor going out to customers. You see pictured here a half MGD unit, and in the back there is actually a 1 MGD unit. That's our EM3 and our EM10 units. This is also an EM10 in the lower right-hand picture there. These units are made in the USA. Our manufacturing is located in the northwestern U.S., and so that's we can provide the support necessary to keep your system online continuously. So just to kind of summarize this unit process before I move on to our other treatment technologies that we can provide for effective treatment and discharge compliance, we really believe that this is a key to an effective process. One, you run without chemical. It's very easy to operate, small footprints. It's fully automated. It's modular, and you increase the capacity and capability of your downstream treatment process, whether it be a DAF, a biological system, a filtration system. It adds superior performance to your entire treatment process. And again, it's a low power input, very much reduced power, not only within the system but within your downstream train, because you're removing so much of the load. Now, I do want to transition to other treatment options that can be provided based on need. The EcoMat and other clarification systems, they remove high amounts of TSS and BOD, as I've mentioned, but there are some applications where further BOD reduction is required. Maybe getting to a discharge level of 200 or 150 milligrams per liter BOD isn't enough. Maybe you got to get to 50 or 20. So in that case, you're looking at a biological treatment process because all of the remaining BOD is going to be completely dissolved. Another application or situation that might require biological treatment is if you have any need for nutrient removal. So those are a couple of situations where you might have that need. And Blue Water has a technology, or several technologies actually, for biological treatment that could be readily implemented. This is an MBBR system. They're great because they have a compact footprint, typically a slightly higher energy input than activated sludge, but again, you get that reduced footprint savings, very capable treatment. It is a fixed film process, so it's fairly shock resistant as well. So again, Blue Water can provide biological treatment options for either nutrient removal or BOD compliance down to lower levels. In addition to biological treatments, we have a product line of, or several product lines of clarification units. We have conventional clarifiers, which typically are not used a whole lot in poultry applications. But conventional clarifiers, I would also input lamella or incline plate settler technology. Our incline plate settler is branded the EcoMat 55 IPS, and that again is a compact clarification unit, but again non-typical for this industry. So I'm going to focus on DAF clarification. We have our EcoDAF system. It's great for TSS and BOD reduction. Single unit capacity is very modular, anywhere from 5 to 1,500 gallons a minute, and we have a very consistent track record in the poultry industry for treatment using this technology. So in this slide, you see some of the key benefits of a DAF system. So if you have an outdated DAF system that doesn't quite match up to this level of performance, we can do retrofits to the whitewater system that increases performance. If you don't have any treatment, this is a great first step towards significant cost reduction in surcharges. You can get 90% of your TSS, 80% BOD reduction, and virtually all of your fats, oil, and greases out in this compact footprint. So again, benefits: enhanced treatment efficiency, very good implementation or application to removal of difficult suspensions, very fine particulate or floatables. You can get a lot of nitrogen and phosphorus removal. And with appropriate design, it is lower chemical cost, lower energy cost, and lower space requirement than some of the alternatives. And kind of in regard to the bench testing or the pilot testing conversation I had earlier with the EcoMat, we do the same thing with our DAF systems, and sometimes we'll do it as we're doing an EcoMat pilot to help optimize the existing chemical regime. So we prove out that we can get a chemical cost reduction and then show that treatment either with jar testing or with a pilot system on site. Now, nutrients traditionally haven't been a huge thing in the poultry industry, but I'm bringing them up because they're becoming more and more important. If you're discharging to a public works system, you're going to see them more and more on the discharge, the surcharges, and typically they'll be fairly expensive, especially regarding phosphorus and nitrogen, because the municipal plants typically the poultry discharge, the water, has a high level of nutrients, phosphorus, nitrogen, and that's a high load to their plant that they're going to charge you for. So we do have some really good technologies for reduction of nutrients. Actually, that's one of our primary businesses in other markets, actually the municipal market itself. Our brand is the Centraflow filter. It's a media filter that provides water reuse quality filtration. So if there's any opportunity for water reuse in the plant, this is a key technology that you'll want to consider. Like I said, it does supply water reuse quality filtration. You can get a reduction in the amount of water that you're bringing into your plant for usage, and you get a reduction in the water that you're discharging from your plant. So there's a couple of opportunities for cost savings just in polishing the water of solids. In addition, we can implement processes, the Blue Pro process and the Blue Night process, to remove nutrients. And we can remove phosphorus all the way down to below most any compliance level I've seen throughout the U.S. We have installs that are operating at less than 0.05 milligrams per liter, which is lower than most people will see. Most people are in this next round of permitting for a lot of plants. They're seeing maybe a 0.1 or a 0.07. And then we also provide the Blue Night system, which can polish nitrates down to below detection limits. And we've, again, installed those in applications where the influent might be nitrogen-rich, up to 200 milligrams per liter of nitrates, going out at less than 10 or less than 5 or less than 1, whatever the requirement may be. So I'll give you, over the next few slides, just a really brief overview of our nutrient technologies. I'm going to return to this concept of the media filter because it helps to understand the phosphorus removal processes and some of the benefits of polishing filtration at the back end of a treatment system. So your influent water comes in, this cross-section will give you an idea of the process flow through the filter. And your influent comes in at number 1 here in the upper left. It actually flows down through a central assembly and is discharged to the media bed through radial distribution arms. So this is a circular tank. It can also be a square tank as well, but let's just stay with a circle for now. The water flows upward through the media. So this is a continuous backwash, upflow media filter. And so you get the clean water filling the head space and overflowing a fixed effluent layer at the top of the filter, discharging at 5 to the right. Now, a portion of that clean water goes up through a wash box, which you can think of this as a small open cylinder on the bottom. So just a portion of the water from this headspace flows up through that. It's typically about 5% of the forward flow. It flows over a fixed effluent weir and it carries out all of the solids that were captured in the media, any nutrients, etc. And so that's your backwash stream. And that's typically recirculated upstream to a clarification system, or there'll be a clarification system integrated in parallel to take care of the solids in that stream. The media, on the other hand, this is a gravity sand filter, so the media flows downward by gravity. There's a central pipe integrated through this filter that will take the spent media with all of the solids that were collected, with all the nutrients that were absorbed and removed, and it carries that media to the top of the filter into this wash box area here at 7. Now this wash box has concentric rings, and through this system you'll get the solids are discharged from the media through a scrubbing action, and also from being jarred through those concentric rings and falling through a tortuous path back to the top of the media bed. So you get separation of the media from the solids that are captured. And again, the solids go out with the reject stream. The clean media falls back to the top of the bed to repeat that process. So some of the nice things about this filter system, it's continuous backwash. There's no cycling. It just runs, period. There's no moving parts, so very low life cycle costs, very low operations and maintenance costs. The shortest life cycle for any component of the system is probably the airlift tube, and that's PVC pipe. That's got a 10+ year life, and those are a cheap 5-minute replacement as well. So very low life cycle costs, no moving parts. And again, the water reuse quality filtration. They are California Title 22 approved for reuse. And they're also approved in multiple other states as well. But since California is one of the more stringent, that's typically the one we'll advertise the most. Now I'm going to focus on nutrient removal over the next few slides. For phosphorus removal, the real key to our life cycle benefit and chemical cost minimization is the adsorptive properties of our process. So what's been very traditional or conventional in water treatment is the use of coagulation and then filtration to remove phosphorus. Well, blue water doesn't do that. Coagulation and filtration, just to give you an illustration, is you dump a coagulant, a chemical, into solution, a bathtub, a clarifier, and you try to form a large enough particle size that it will not fit through the media. So it'll get trapped in the interstitial spaces of the media. what that leads to is a plugged filter. You're always operating a semi-plugged filter, and it's not very efficient chemically. What we do is we actually coat the media with a metal salt. So we add a ferric salt typically to coat our media. It gives a very homogeneous ferric hydroxide coating to the entire sand granule. That's what we use, the silica sand. So it's a commodity media. It's a commodity chemical added to create that coating. And what that coating does is it will absorb phosphorus. So rather than relying on diffusion in a big bath, which is what coagulation does, we guarantee contact between any dissolved phosphorus in the stream and the adsorbent, the substrate, which is the ferric hydroxide. So you're guaranteeing contact. A media bed that has 60 inches of depth has an astronomical surface area. So very high efficiency uptake of dissolved phosphorus in this system. That's really the key to minimizing the chemical and operations costs and achieving compliance levels. Here's a couple of case histories I'm going to share with you regarding phosphorus that we've done around the country. And this is more to illustrate the size of systems that we've done, because there's challenges that are unique to very small systems and very large systems. So this first one will illustrate some of the challenges that were overcome with a very small system. 2 CF7 sand filters, 25,000 gallons per day peak flow on this particular system. But they had a very stringent phosphorus requirement. So they have intermittent flow. There's a recycle tank on this process. But you can see here the design was very capable. This was just a month of operating data from last year, actually. So you can see the compliance level highlighted in red. There's two stages to this treatment system just to guarantee compliance. And you can see that with stresses to the system, sometimes that first stage will go over the compliance level. But largely it actually meets it. In the second stage, you're guaranteed that compliance level for this particular system. So there's a good example, a strong example of a case where the system was very small but very well designed and very capable. This next story that I'm going to share with you is on the other end of the scale. It's a very large system. It peaks at 12 million gallons per day treatment flow. So again, this is another technology that's very modular, very expandable for treatment, and very flexible for levels of treatment compliance. Many of our industrial discharges might only need to meet a milligram per liter phosphorus. That's pretty typical. Some are being pushed to 0.1. It's fairly rare. It's mostly in the Midwestern states like Wisconsin, Minnesota that are having to meet anything more stringent than 0.1 as an industrial discharger. But again, here's a case where they are definitely meeting a 0.1. They're actually permitted to 0.07 in maintaining that level very well. It's been this one is in Marlborough, Massachusetts. It's been operating now for a little over 2 years. Now, in addition to phosphorus removal, we can do denitrification, and we can do it within the same treatment stage, within the same treatment vessel as the phosphorus removal, which is one of the strengths of our technology. So you get polishing, filtration, you can get phosphorus removal, and biological denitrification all in the same treatment stage. This case study is from Texas. The total phosphorus coming in from this treatment, obviously there was a biological treatment plant up front, but the phosphorus level was down to 3.4 average coming in, and left at 0.14. Their permit was 0.2. Pardon me. And then nitrate compliance, they were coming down from nitrates greater than 10 to less than 2.2. Their compliance level there was 2.5. So very economical system, because you get multiple benefits from one treatment stage. You very low chemical inputs. You have a ferric sulfate in this particular case for the P removal, and again, that's just to coat the media for this system. And then we're adding either a methanol or a glycerin product, some other carbon source potentially for removal of nitrates, to convert nitrates to nitrogen gas biologically. So again, a very successful case study for implementation of those nutrient considerations. I'm going to leave that now and just wrap up with some of our manufacturing capabilities. So you've seen sampling of our processing equipment. Our manufacturing capabilities allow us to provide not just unit processes but solutions. We're not just providing a cookie cutter insert that you can fit into your treatment scheme, but we can work with you and provide a well-integrated treatment system that'll fit into your puzzle very nicely. Again, I will highlight that we have a UL listed panel shop, so we can do completely customized controls. We do have mobile systems as well, which probably not extremely interesting within the poultry industry, other than to demonstrate and to prove out the technology. But again, I will highlight that we're a U.S.-made company. Talking about Blue Water's pilot fleet, I want to wrap up with some of the benefits. Obviously, you can see a wide range of capabilities in these pictures. Here's a turnkey sand filter plant that can do all of the nutrient removal, so that can pilot turnkey nutrient removal on site. There's a clarification plant, our EcoDAF system, that can demonstrate clarification, as well as our EcoMat rotating belt filter down here in the lower left. This is a pilot system that's mobilized. It's actually, this is in excess of 1 million gallon per day capacity, so this will do quite a large flow. But we can mobilize this system as a pilot system as well. And as I mentioned, the benefits are treatability projects, contract treatments, while there's doing a design build to save money in the interim. You can do an economic analysis, a short-term pilot study, and also demonstrate it for engineering or plant manager confidence, basically. So with that, I'd like to conclude our presentation today. I hope that I have sufficiently shared our methods for managing overloaded systems or discharge challenges. We can help reduce the financial impact of water treatment to your plant. We've highlighted increases in rendering revenue. Recapturing a waste stream, turning it into revenue that can help pay for the water treatment and disposal throughout the poultry processor, the kill plant. And in addition to that, with integration of our EcoMat rotating belt filter or other unit processes, we can decrease overall chemical usage, power costs, and hauling costs. So those are all cost reductions. In addition, surcharge reductions. If you're discharging to a public works plant, a municipal plant, sewage plant, and then in addition to that, if you can get any reuse, there's a decrease in water usage and cost as well. So I hope that gives you kind of a broad overview of what Blue Water focuses on in new projects. With that, I'm going to open the floor to questions. So if you have any questions about anything that I've discussed, please write them into the text box. So one of the questions that came in was just a compliment on the presentation and asking whether the presentation will be available either in hard copy or as a presentation video. And typically we will upload these to our website. So after the presentation, this will likely be uploaded to our website for viewing. So another question is Max TSS influent to the Blue Pro filter. So again, this is a polishing technology. So it's a media filter on the back end for nutrient removal, specifically phosphorus removal. And there's typically upstream treatment. Our Max influent TSS on average, we can design around 50. We can manage spikes upwards of 80 to 100, but again, that has to be a design consideration so that you can appropriately recover from those spikes of TSS. So typically what we will do when we're integrating this is it's typically after a well-designed and operating DAF system or some other clarification system. One of the next questions is, what's the availability of a pilot unit for a new project this year? And we have several pilot systems that are circulating the country. I would say the lead time on a pilot is anywhere from 4 to 8 weeks. But you can contact sales at bluewater.net to arrange or schedule a pilot. If you're working with a regional sales manager from Blue Water, you can arrange a pilot through them or through a sales rep for your region. And all of that contact information is located on our website. I believe I'm sharing my screen, so I'm going to open up our website and point to where our contact information is. So if you go to contact, there's a map of the world. You can see where we're represented throughout the world with sales reps primarily. And you can click on the U.S. There's a map of the United States and wherever you're located. Most of our business for poultry is in the southeast, obviously. So if you click on any state, it'll bring up the contact information for the local representative. Another question is, how helpful is lab testing? So I will say that lab testing is very important to design and a great tool for preparing for a successful pilot. So just knowing accurate water quality is very important. You know, your average TSS, BOD levels, fog levels, that's all very important. The operation performance of an existing system, if you have it, that's all very important as well. But let me stay focused on lab testing, I guess. We can bench test any unit process. So our DAF system, we can do jar tests to optimize chemical and to optimize settling velocities for, or separation velocities, I should say, for our DAF system. We can also bench test our EcoMat filter, and that's basically a litmus test as to how it'll work. You don't get performance numbers off of your bench test, but you do get a very strong indication of what level of performance is achievable. So typically that's our litmus test to justify coming in and doing a pilot and going through a design phase. So I hope that sufficiently answered the question. Somebody asked a question, what levels of phosphorus are considered too high for treatment? And I'm going to answer that with there's not really a too high level of phosphorus for treatment. We have various industries where we do phosphorus removal, including fish farms, which traditionally have very high phosphorus, and they're typically upwards of 20 milligrams per liter. And we usually maintain about 90% removal of phosphorus in an individual treatment stage. So it's a very effective process. And a lot of times we'll take advantage of conventional technologies in combination with our adsorptive technology to let each of them work in their sweet spot. Because conventional technologies are actually fairly efficient down to less than 5, less than 1 milligram per liter, and then our adsorptive technology becomes a real money saver in chemical usage. So if you're really interested in nutrient removal, phosphorus removal specifically, we are having another webinar next week that'll highlight a lot of our phosphorus removal specific installs. We have an engineer who's going to be a guest speaker for us, who's installed 3 different plants in the state of Minnesota and Wisconsin. He's got a lot of experience with phosphorus removal, not only with ours but with a variety of systems. And now he's pretty comfortable with our system as well. Oh, if you are interested in that, please email I believe I have a contact email here. Oop, I lost it here. Okay. I don't have a contact email. Sales@blueh2o.net, or click on the website. You'll see contact emails for Blue Water sales personnel. If you send them an email, they can get you an invitation to that webinar if you have nutrient-specific questions. Okay, another question regarding dewatering. Is dewatering always, or how do you predict dewatering capability? Now, dewatering is kind of an iffy thing in the poultry industry. A lot of it has to do with particle size, and it's going to different from application to application. I would say in roughly 50% of the applications we've been able to achieve some level of dewatering, which will take the solid slurry coming off of our EcoMat rotating belt filter from roughly 7 to 10% solids to in excess of 20% solids. But there's other applications where the particle size is just too fine. It's been ground. Excuse me. The particles that are suspended in solution have been ground too fine. They're more oily. There's less fiber in the water, and those are applications where you're basically stuck with the level of solids that are coming off of the rotating belt at 7 to 10%. And again, that can be higher because again the water content's fairly low. It has a fairly high grease content normally. There are a few technologies that we're looking at for improving that because again we'd like to offer dewatering to every application. What are typical replacement parts and costs for the EcoMat rotating belt filter? Okay, so I mentioned low life cycle costs for a lot of our equipment, including the sand filters. You know, it's a non-mechanical system, so that has very low operations and maintenance life cycle costs. DAF systems, same thing. You have a couple of pumps that may or may not be need to be replaced throughout the life cycle. EcoMat is actually very similar. You do have bearings. You have a head roll and a tail roll. And I'm actually going to go to a cross section of that system so that we can look at the mechanical components more closely. Here we go. So here's a cross section of the system. There's a tail roll, there's a head roll. Those obviously have some bearings. They're sealed bearings. They typically have a 5 to 10 year life. There's two motors on the systems. There's a head motor and a conveyance motor, if you have conveyance. And again, those are small motors. We're talking about a horsepower, 1 to 2 horsepower. There's a 2 horsepower on that auger, 1 horsepower on that head pulley. So the mechanical components of the system are pretty simple. Life cycle analysis, typical replacement parts. If you burn out a motor, you know, that's typically a 10-year kind of item. Bearings. There's some miscellaneous seals that might need periodic maintenance over the course of 3 to 5 years, but those seals are, you know, small dollar value parts. Life cycle of this unit again was this unit was designed to be a very minimal operations and maintenance kind of economic benefit. Another question is how easy is it to simulate phosphorus testing on the bench scale? Because I believe I talked about EcoDAF systems on the bench scale and the EcoMat. We can also do full simulation of our nutrient removal and filtration processes on the bench scale as well. So that includes our adsorptive phosphorus removal. We actually do a lot of bench testing for other industries, not just phosphorus, but for metals compliance as well, like zinc and copper and lead. We do a lot of power plants with that same polishing technology. And we can simulate all of those on the bench scale as well, which is a great way. Again, I mentioned the bench scale test is a great way to do a litmus pass-fail, so to speak, on the project, and justify going into either a pilot or design. Most applications in the poultry industry are pretty straightforward. You know you're going to get X removal. It's just about gaining finalized parameters for sludge management and operations costs. and chemical savings downstream, and whether you might have an existing system like a DAF or a biological treatment system downstream. It looks like I've come to the end of my questions, and we are come to the end of our time today. So I want to thank you all for joining me on this webinar. I really hope to meet many of you personally on your future water projects. So again, thank you for joining Blue Water on this webinar. If you have any further questions, feel free to email me directly. You can find my contact information on the website, or any of our sales representatives or regional managers. Again, have a nice day. Thank you.